So today we're going to do another quick, like 7-minute run through of a chapter. Right here in front of you, I have Physics for Scientists and Engineers, the 10th edition, and you can see chapter 35 is actually image formation. The previous chapter, 34, is the one on the nature of light and geometric optics. And the reason I'm showing you this is because over here I have Physics for Scientists and Engineers, the 7th edition. Let me just double check if that's true. Yes, the 7th edition. And you can see the chapter is different. Image formation is 36. And in the 10th edition, image formation is 35. And you can see the sections over here are also a little different. So this is, again, the 7th edition. Let's take a look at the sections. 36.1, images formed by flat mirrors. Point 2, images formed by spherical mirrors. 3, images formed by refraction. 4, thin lenses. 5, lens aberrations. 6, the camera. 7, the eye. 8, the simple magnifier. 9, the compound microscope. 10, the telescope. So those are all the sections of chapter 36, image formation, for the 7th edition. But if we go back to the 10th edition, this is the more updated one, 35. You can see they've actually removed some sections. So we still have images formed by flat mirrors, images formed by spherical mirrors, images formed by refraction, and thin lenses. And we have lens aberrations. And then they have 35.6 optical instruments, which looks like it combines this entire section right here into one big section. And this might be different from your version because the one I have in front of you here is version 7. The one I have over here is version 10. I think version 10 is the latest, but you might have version 9, 8, 7, 6, whatever. So I'm just showing you that there might be a bit of differences, but overall the content should be roughly the same. You know, if you read from one book, you will have a broad, if it's actually the same section, you know, it's introducing the same content, you'll have the general information that is important no matter which book you're reading. But just keep in mind that sometimes you might miss out on a couple of things that were removed or changed for in different editions. So let's try to do a 7-minute run through. I'm gonna set a timer for 7 minutes.
All right, 7 minutes.
And let's get running. This chapter is concerned with images that result when light rays encounter flat and curved surfaces. Images can be formed by either reflection or refraction and can design mirrors. Okay, cool. So I'm just going to take a look at first sentences of each paragraph. I'm going to look at images and I'm going to just try to get a big view of what's happening here. So I can see this image over here looks pretty interesting. We have an object, rays of light in orange with the direction of travel, and they're reflecting off a mirror. And then here I have an image formed by a reflection from a flat mirror. The image point I is located behind the mirror and a perpendicular distance q from the mirror. Okay, images formed by flat mirrors, 36.1. Let's actually just read the bolded stuff here. Images are located either at a point from which rays of light actually diverge or at a point from which they appear to diverge. All right, images are classified as real or virtual. A real image is formed when light rays pass through and diverge from the image point. A virtual image is formed when the light rays do not pass through the image point, but only appear to diverge from that point. That was really confusing, but I'm going to keep pushing through. Just take a look at the image. I'm not even going to read it. Here is a yellowed out equation. Capital M equals image height over object height. Okay, pitfall prevention, quick quiz, and some examples. And then we go to 36.2, images formed by spherical mirrors. Okay, I'm just going to take a look at the section titles here. We have concave mirrors, and they show you a picture of a concave mirror here, and they show you some other concave mirror images here. A satellite dish, pretty cool. We have another equation here in yellow, which is, just taking a look at the timer, 4 minutes 50 seconds, not bad. So this equation here, capital M equals H prime over H, which equals minus Q over P. All right, I'm not gonna worry about that too much. Oh, I see bolded words, focal point, focal length, mirror equation. P, Q, and F are letters that are appearing fairly frequently. Cool. Okay, we've reached the next section in the next subsection, I should say, convex mirrors. So we have concave and convex mirrors. Next subsection, array diagrams for mirrors. Okay, we have a little table here that looks important. Sign conventions for mirrors, quantity, object. Okay, this looks a little confusing, but I can see the letters P, Q, H prime, F, capital M. So a bunch of letters that I've seen before. I'm just going to keep that in the back of my mind. Like, we'll probably come back to those letters. Then we have a big section here in yellow, which looks pretty important. Ray 1 is drawn from the top of the object parallel to the ray 2 is drawn, ray 3. Okay, we'll come back to this, but I'm going to keep that little yellow section in mind. It might be important. And I can see, again, the same letters, P and F, in there, the italicized. Some other diagrams here. We have part A here is a concave mirror. Then we have another concave mirror. And then we have part C here is a convex mirror. Another yellowed out section with 3 points. Quick quiz, an image, and an example. And the solution of the example. Pretty big example. We have another example here, 36.4. And we've reached the next section, 36.3. I have 3 minutes on the timer, and man, there's quite a lot of sections here. Let's bulldoze through this again very quickly. Images formed by refraction. Okay, looks like we've moved away from reflection, and we're at curved surfaces. This to me, and we see Snell's law over there, the law of refraction. Something yellowed out. Another little table. Flat refracting surfaces. Okay. Couple examples. Few examples. Some solution. Okay, 36.4, thin lenses. Image formed by one refracting surface serves as the object for the second surface. Okay, I think that makes sense. Again, something that looks like the cross-section of some glasses or contact lenses. That's just kind of what I think in my mind. Another F equation including F and focal length. So, okay, F could be focal length. Nice, I learned something there. A couple of other interesting looking pieces of glass. Again, an equation with P, Q, and F. And underneath it in bold is the thin lens equation. Then we have another subsection, magnification of images. Timer is at 1 minute 30 seconds. Ray diagrams for thin lenses. Oh my goodness, a couple more boxes of yellow. Examples. Let's keep going. A couple more images, or yeah, subsection combination of thin lenses. All right, combination, and then they show you here an example with 2 thin lenses next to each other. 36.5, lens aberrations. I don't think I have enough time to even go through this. Timer is at 1 minute. Chromatic aberration. I have no idea what aberration means, and I don't have time to go through it too much. 36.6, the camera. I'm assuming this just explains how a camera works. An example, 36.7, the eye. Okay, I'm assuming this explains how the eye works, conditions of the eye. Ooh, farsightedness and nearsightedness and presbyopia. Some cool kind of medical terms, farsighted and nearsighted. I've heard those before for people that need glasses. Astigmatism, another word I've heard. 36.8, the simple magnifier. Timer is at 25 seconds. Oh my goodness, let's keep pushing through the compound microscope. All right, the telescope. And the summary. And we finish with 15 seconds left. Let me stop this timer here. So that was a 7-minute run through of the chapter. As you can see, it was as rough as the 7-minute run through of the previous chapter, but I think it was good enough to go through that. Let's take a look at the summary real quick. Definitions: the lateral magnification M of the image due to a mirror or lens is defined as the ratio of the image height to the object height. Okay, I saw that. I feel fairly comfortable with that. I haven't used it in any examples yet, but I also remember Q and P. It is equal to the negative of the ratio of the image distance Q to the object distance P. So Q and P are distances. Then we have height and height prime, which are heights. And we have M, which is lateral magnification. All right, let's take a look at the next section. The angular magnification, lowercase m, is the ratio of the angle subtended by an object with a lens in use. Okay, I'm not going to read any more of that. The ratio of the focal length of a camera lens to the diameter of the lens is called the f number of the lens. All right, and we have f and diameter there. So f, I think, is focal length, the lowercase italicized f. Concepts and principles. In a paraxial ray approximation, the object distance p and the image distance q for a spherical mirror of radius r are related by the mirror equation in bold. And then we have 1 over p plus 1 over q equals 2 over capital R equals 1 over f, where f equals r over 2 is the focal length of the mirror. Okay? An image can be formed by refraction from a spherical surface of radius r. The object and the image distances for the refraction. All right, that's also a little confusing. Oh, it continues here. The inverse of the focal length f of a thin lens surrounded by air is given by the lens maker's equation. That is a cool name for an equation, the lens maker's equation. I like that. 1 over f equals n minus 1. N to me looks like the index of refraction from the previous chapter, but I also am not too confident with my knowledge on the index of refraction, so that's just something I'm jumping out at me a little bit. And then in big brackets, 1 over r1 minus 1 over r2. Converging lenses have positive focal lengths and diverging lenses have negative focal lengths. For a thin lens and in a paraxial ray approximation, the object and image distance are related by the thin lens equation, 1 over p plus 1 over q equals 1 over f. The maximum magnification of a single lens of focal length f used as a simple magnifier is this. The overall magnification, okay, I'm going to stop there. So, as you can see, very quick run through of the chapter, and it is dense with information, but it is readable in 7 minutes. Like, I zoomed through it. Of course, I didn't get every piece of information from this chapter, but I got a broad, big overview. And I know that this entire section is related to how we can use reflection and refraction for different geometries of lenses and mirrors. We have mirrors, we have lenses, we have different optical devices near the end of the chapter, and we have some equations related to focal length and stuff like that. So chapter 35 in the 7th edition, remember that this is different from the 10th edition, which is here. And if you want, we can actually zoom through this very quick to see if it's the same. Images formed by flat mirrors. Some of these pictures look already the same. Here's that capital M. If you remember, that is the same equation as we saw before. Maybe we have some different examples. I'm not too sure. Images formed by spherical mirrors. Okay, similar looking equation. Satellite dish, all right. Focal length, mirror equation, convex mirrors, looks like the same type of stuff. Ray diagrams for mirrors. Same kind of looking table that I was confused with. Oh, in this section they have these 3 points that were yellowed out in the 7th edition. Now they use blue. Not sure why. I kind of like the yellow a little bit more, but you know, to each their own. So we have a couple examples again. The examples might be the same or they might be different. Images formed by refraction. To me, this looks kind of exactly the same as the 7th edition, but they could have made some little tiny changes. Some examples. Images formed by thin lenses. Looks to be like the same stuff. Lens maker's equation, let's go. Thin lens equation, magnification of images, array diagram for thin lenses. Here are all these highlighted points that we're going to go deeper into another video. Combination of thin lenses. I just want to see the end part of this because this 10th section doesn't include like the eye, the camera. It just says like optical devices or something like that. Lens aberrations. I have no idea what aberration means, so maybe I'm gonna Wikipedia or ChatGPT search what that is. Optical instruments. Okay, here actually they have subsections. The first one is the camera, then it's the eye. Nearsightedness, the simple magnifier. It looks like the exact same stuff. The compound microscope. Yeah, they just kind of shortened it to put everything in one section. The telescope, and they called that entire section optical devices, and they just use subsections instead. So here's the summary here. Looks like kind of the same stuff. They've shortened it to fit it on like one page here, and then some problems. So this is another thing you could do if you have different versions of the textbooks. You can take a look at each. Maybe it'll make it a bit more fun for you to read through it. But yeah, I hope this was helpful. Have a good one.